one-sided limit. A limit exists if the left side limit equals to the right side limit. So we have limit as x approaches to a of f of x equals to L if and only if the left limit and the right limit, they are both equal to L. Let's look at an example. So we have g of x equals to a piecewise function, and then we have the graph of piecewise function. I want to find the limit of g as x approaches to 1. All right, so let's do it. The limit as x approaches to 1, x approaches to 1 from the left side and from the right side. All right, so what we are trying to do is we check the left side first. X approaches to 1 from the left. X minus 1 divided by x squared plus 1, right? So that is a limit. You can factor the denominator. So that is x minus 1, x, this is a minus, right? We have to be really careful. This is a x squared minus 1. So we have x plus 1 times x minus 1, and then they got cancelled. We have limit as x approaches 1 from the left, x minus 1 divided by x plus 1. Are we safe to plug in? Yes, we are. So plug in 1, we have, it's not x minus 1, it's 1, right? And then we plug in, so we have 1 divided by 2. So the left limit is equals to 2. The right limit as x approaches to 1 from the right, we have x, same thing, right? I will just write the simplified form. 1 divided by x plus 1, we plug in a 1, we have a 1/2. So this left limit and the right limit, they are both equal. Therefore, we can say that limit as x approaches to 1 from either side, the function is equals to a half. I know, if you just look at the function individually, at x equals to 1, the function doesn't exist because we have an open circle, right? But this is how we define the function, the first piece, the rational function. We said that this function is defined when x is not equals to 1. So that's why there is an open circle. I will still graph the function, but I am going to strongly specify that x cannot be equal to 1. When x is equals to 1, we have a 2, which is a point right here. This is a 1 comma 2. Is this a function? Of course, because it passed the horizontal line test, right? Not horizontal line test. The vertical line test. You draw a vertical line. This vertical line touches 1 point only. So that is still a function. The vertical line test is passed. And then we do a one-sided limit, one on the left, one on the right. They are equal. So overall, the limit of the function as x approaches to 1 is equals to 1/2. And then what about g of 1? G of 1, so we just change back to the color. G of 1, when x is equals to 1, you get a 2. So 1 comma 2 is a solid point. That is how we do the one-sided limit. Again, the limit exists only if and only if the left limit and the right limit are equal. If this is a 1/2 and this is a 1/4, then overall the limit doesn't exist. I have plenty of examples to give you. So let's take a look at the next example. So we have a big picture, all right, and then we want to do this limit. All right, so we have x approaches the limit of f of x as x approaches to -4 from the left. Where is -4? -4 is right here. -4 is right here, right? So as x approaches to -4 from the left, where is left? This is left, right? This is right. Your left hand and your right hand. As x approaches to 4 from the left, what do we get? We have y equals to 3, right? Y equals to 3. As x approaches to -4 from the right, y is equals to -2. I need the equal sign. That is equals to -2. So since they are not equal, what do we say about as x approaches to 4 from either side? We say the limit, listen, does not exist. DNE. DNE means does not exist. What about f of negative 4? F of negative 4 is equals to 3 because negative 4 comma 3 is a solid point right here. As x is equals to negative 4, we have a solid point. Let me erase that so you can see it. As x approaches to as x equals to, when x is equals to negative 4, we have one solid point right here. All right, so that's why f of negative 4 is defined. What if this is an open circle? This point right here, look, this point right here is an open circle. If this point is an open circle, that means f of negative 4 doesn't exist. All right, moving on to the next one. The next one we have f of x as x approaches to negative 1. Where is negative 1? Negative 1 is right here. Negative 1, this is left, and then this is right. As x approaches to negative 1 from the left, we have y equals to 4. This is also equals to 4, so they are equal. The left limit and the right limit, they are equal. So when x approaches to negative 1, did I miss the plus right here? Okay, so this one is a minus. This one I'm going to put a plus right here. Okay, so and then this one we delete the plus. So left limit, and then a right limit, they are both equals to 4. So as x approaches to 1 from either side, the limit is just equals to 4 because the left and the right, they are the same. It's like you are driving. You are driving from this direction, left, and then from this direction. You stop at the same point. This is your left, this is your right. You drive from the left, you stop at this point. You drive from the right, you stop at this point. That means this point is solid. The limit exists at that point. What about f of negative 1? When x is equals to negative 1, we have a solid red point that is equals to 4. Because negative 1 comma 4 is a solid point. All right, moving on to the next one. It looks like we are looking at a 2, right? So we are looking at a 2 from the left, and then from the right, from the left. This is left. Let me switch color for a new problem. I'm going to switch to orange. This is from the left. This is from the right. So from the left, we have y equals to negative 1. From the right, we have y equals to 5. Are they equal? No, they are not. They are not equal. So what happens when they are not equal? As x approaches to 2, there is no plus or minus, right? From either side, then the limit does not exist. What about the point itself, f of negative 2? Well, and when x is f of 2, not negative 2, when x is equals to 2, right here, the y value is equals to negative 1 because 2 negative 1 is a solid point. And then the next one, we have a 4 and a 4, right? Let's look at a 4 and a 4. So 4, right here, we have a left side, we have a right side. So left side and right side, they are both at y equals to 2. So this is y equals to, come on. I want to line this up. Done. Okay. 4, okay, what did I just say? Y equals to 2. So this is equals to 2, this is equals to 2. So since they are equal from either side, that is equals to 2. But what about f of 4? If you look at f of 4, this is an open circle. Open circle means undefined. When x is equals to 4, nothing is defined. That's why they use an open circle. If they use an asymptote, same thing, nothing is defined. All right, so that is the exercise for the one-sided limit. So again, the big idea is to check a limit, you have to check the left side, you have to check the right side. If left and right equals to the right, they are equal, the limit is equal to that value. Otherwise, the limit does not exist. Okay, I will see you all in the next part.